complex numbers. Now there's quite a bit of notes and examples that's going to go with today's, so it will be kind of a little bit longer lecture than usual. So make sure you got pencil, paper, and if you need to, pause and come back later. But we talked about at the beginning of the school year how right now everything we have is real numbers, or rationals, irrationals, and all those number sets. Well, imaginaries is where they're not real. All right, and imaginaries came about because we just were bored. You know, we need something more than just real numbers. So we decided, what the heck? Why not have some imaginaries? Well, these imaginaries came from the square root of -1. The square root of -1 is I. That's an imaginary. Anytime you square root a negative, that's an imaginary. So that's the only place the imaginaries come from, is the square root of a negative number. We use 1 just because that's the easiest one to deal with. But imaginaries come from anytime you take a square root of a negative. It doesn't matter what other number is there. And we'll talk about that here in a little bit. Imaginaries are cyclical. What that means is that they go in a cycle. All right? There's more than one type. If I have I squared, I times I is I squared, it actually simplifies to -1. When I have I cubed, well, that's I times -1, because that's 1I, 2 i's makes 3. So I times -1 gives me -I. And we have I4. Well, I4 is 2 2's, right? I squared. So I4 is really -1 times -1, which is +1. Well, that's also the same as I0, right? If I were to put I0 up here, anything to the 0 power is 1. So it's cyclical. If I were to do I5 is the same as I3 and I2. Well, that's +I. There's I5. If I did I6, well, that's I3 and I3. So -I and -I is I squared, which is -1, which is there. And it's going to keep continuing going on this way in this cycle. So I have I0, there's I1, I2, I3, same I4, I5, 6, 7, 8, 9, 10, 11. So what we have here is that these are, we need to be able to find any I at any power. The way we do that is we just look at the remainder. So if I have, let's say, I27. All right, I could count. I could go, okay, here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I could keep in mind there's our 4 that we're talking about. And I could keep counting and counting and counting. But I really don't want to count up to 27. So what I look at is the remainder when dividing by 4, because that's how many there is. And I would go, okay, 4 goes into 27. 6 times, and I get a remainder of 3. So I-27 is actually negative I. And if I'm sure, again, I can count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27. I-27 is negative 1. We don't want to count every time. All right, so what about I-101? Well, how many 4s go into 101? We really don't care, but there's 25 of them. What we care about is the remainder is 1. So I-27 has 1, so that's just I. I-16. Well, 4 goes into 16, 4, with the remainder of 0. So the remainder 0 is the exponent. 0 gives me 1. It is always cyclical. You're either 1, you're either I, negative 1, or negative I. Those are always the values. No matter what exponent we have, those are the only 4 values we can come up with. And we can come up with the value by dividing the exponent by 4 and seeing what the remainder is. The remainder is the exponent. Exponent 0, exponent 1, exponent 2, exponent of 3. Alright, so that's where imaginaries came from. They came from the square root of a negative number. Imaginaries are cyclical, meaning they can have 4 different values based on their exponent. We use these imaginaries in complex numbers. What we have is we do real, plus or minus, complex, and we call that standard form. A is the real part, and BI is the imaginary part. So 2 plus or minus 3i is a complex number, where 2 is the real part and 3i is the imaginary part. Negative 1 plus minus 4i. Negative 1 is the real part. 4i is the imaginary part. That's how you write a complex number in standard form, and it will be expected that you write anytime you do imaginaries in standard form. All right, we're going to do a lot of things with our imaginaries. We're going to add, subtract, multiply, divide. We're going to do all those kind of things. So let's start with adding and subtracting. Whenever you are adding and subtracting, it's the same as any variable. It would not matter if they're X's, if they're W's, if they're hearts and smiley faces. You combine them and do them the exact same way you would any other letter. So if I have a minus outside of a parenthesis, that means we need to distribute it. Plus sign doesn't distribute. And you combine what goes alike. The real number parts go together. So 8 minus 3 is 5, minus 4 is 1. And then the letter parts go together, the imaginary parts, the i's. Negative I plus 2i is 1i, plus 6i. Gives us, what did I just say? Minus I plus 2i is 1, plus 6 is 7. combine them just like you would anything else. Oops. All right, when we multiply, so that's adding and subtracting. Add and subtract them like you would any other letter. When we multiply the exact same. With one exception. Anytime we get an I squared, we change it to -1. And that goes up here. I squared is -1. All right, so let's look at 2 minus 3i times -1 plus 4i. When I distribute, 2 and -1 is -2. 2 and 4i is 8i. Just like it was an x, we multiply the same. Minus 3i minus 1 is plus 3i. Minus and plus is minus. 3 and 4 is 12i squared. So right now, we've just multiplied it as if it was a normal x. Now we need to simplify. -2. This becomes 11i. This I squared is really -1. 12 times, or -12 times -1 makes +12. So put it all together. 10, -2 and 12, plus 11i. Real, imaginary. Always in the same format. Real, imaginary. So that takes care of adding, subtracting, and multiplying with imaginaries. Fairly straightforward. You know, nothing too complicated there. The only thing is when we get an I squared, it is a -1. That means it's going to change the sign of whatever it was multiplied to. And then we combine everything as normal. So now we need to look at division. Dividing imaginaries is the same as dividing radicals. We're going to use what's called the conjugate. All right, let's take a look at something here. 3 plus 2 plus I. All right. Imaginaries is the same as radicals. You can't have imaginaries in the denominators, just like you cannot have radicals in the denominators. But with imaginaries, we're going to have this plus minus sign, which we haven't had yet with radicals, of which we will. And the same rules are going to apply. But you have to multiply by a conjugate. And a conjugate is the same numbers, same order, but opposite middle sign. So for this example, the conjugate of 2 plus I is the same numbers, same order, opposite middle sign. It's going to be that negative. And what we do to the bottom, we've got to do to the top. So we're going to multiply the conjugate, 2 minus I, to the top and the bottom. When I multiply 3 times those, I'm going to get 6 minus 3i. And when I multiply the bottom, 2 times 2 is 4, minus 2i, plus 2i, minus I squared. Whenever you multiply by a conjugate, the middles will always cancel out. That's the whole purpose of multiplying by a conjugate. If it doesn't, then you didn't do it correctly. The I squared we know is -1. So this is really 4 plus 1, because negative, negative makes positive. So put it all together, we get 6 minus 3i over 5. Let's try it again. We're going to do 1 plus I over 3 minus 2i. We don't care about the numerator, we only care about the denominator. You can't have imaginaries in the denominator. So I need to multiply by the conjugate. The conjugate, same number, same order, opposite middle sign. So what I want you to do right now is I want you to pause the video, set up your conjugate, and see if you can work it out, and then come back and follow the steps and see if you were able to match up. So pause the video. Alright, you should have gotten that the conjugate was 3 plus 2i. Same number, same order, opposite middle sign. Now when I multiply in the numerator, I'm going to get 3 plus 2i plus 3i plus 2i squared. That's just distributing normal FOIL, first, outer, inner, last. And on the bottom, I'm going to get 9 plus 6i minus 6i minus 4i squared. So when I simplify on top, I'm going to get 3. Those are going to give me 5i. And this I squared is a -1, so it's going to change that sign to a -2. On the bottom, I'm going to get 9. Those go away. And then I'm going to get this I squared for -1, which makes that a +4. Put it all together. I'm going to get 5. Oops, how about 1? 1 would be a better number. And then plus 5i all over 13. You can leave it that way. You do not need to separate it. If you wanted to separate it, it would be the real part and the imaginary part. You do not need to separate. You can leave it. However, make sure if you can reduce, that you do reduce. All right, so we have found i's to be cyclical. We know our standard form. We can add them, we can subtract them, multiply them, we can divide them. Well, all of these imaginaries, they come off of a graph. Like we said earlier in the year, everything has 4 methods to being done: graphically, numerically, algebraically, and with words. Imaginaries are no exception to this. We can graph imaginaries. And graphing imaginaries is actually much simpler than you might think. In order to graph a complex, oops, I'm going to use A. So there's an A plus or minus a BI. All we do is we associate A is to X and BI is to Y. So if I gave you the complex of -4 minus I, and I said graph that, you would go, it's -4, -1, where this is the x-axis, and this is actually the imaginary axis. But you would just go -4, -1, and there you go. So let's try that again. What about 1 plus 3i? The ordered pair would just be 1, 3. And there you would graph it. If I just gave you 5i, the part that's in the real or the x location, hopefully you know it as 0. And you would label it as such. All right, let's go backwards. If I gave you the point D down here, could you give me the, well, coordinate, but then the complex number of that representation? So could you go that D is 1, -3, therefore its complex is 1 minus 3i. Be able to go in both directions. Giving a complex, find the graph. From the graph, write it as a complex. All right, and the last thing that we need to do with imaginaries is we need to be able to solve them. Solve is the same as any other. Just be careful, if you square root a negative, you get an I. That's going to be the only difference. So here I have x squared is -9. We know it's a square. Square is isolated, so when I square root both sides, I get my x. But when I square root a -9, I know the square root of 9 is first of all going to give me 2 answers. Anytime I square root, I always get 2 answers. I know the square root of 9 is 3. And now I know that the square root of a negative is I. And that's all you do. Just throw an I on the end and deal with the numbers as if they are normal. So let's try again. 2x squared plus 3 is -13. We're going to solve this normal, meaning get the square by itself so we can square root both sides. 2x squared is -16. X squared is -8. When I square root both sides, the x is fine, and I get 2 answers. Always 2 answers, square root, solving. The square root of 8 is 2 root 2. But because I'm square rooting a negative, I got to have an I as well. And that comes out right next to the 2. It does not go in front of the plus minus. It goes right next to the 2 because all of this came from inside. So that means it all goes right in front of the radical. And we always put our number first. We like 2i, 2x, 2y. We always put our number before the letter. All right, so let's try one more. Last one. X minus 1 squared is -7. The square is already isolated. So all I have to do is square root both sides. So I'm going to get x minus 1 is this plus minus of the square root of -7. Now, I can't simplify the 7, but I can simplify the negative. So I need to do that. And because it's with the radical, it goes in front of the radical, so it's just I root 7. But because I'm solving, I got to move that x. And the way I'm going to move the x is that goes in front. So x is 1 plus minus I root 7. All right, so the assignment that you're going to be doing in class tomorrow from the book is going to encompass all of these imaginary information. Yes, I know there's a lot of it. We're going to spend the next couple of days working on them and practicing them.